Hi everyone, welcome to another session of Global Hack Week. I know you've seen me just about an hour ago, so we'll be starting the second stream for the part two of EEG and brain-computer interfaces. For the second section of the stream, I know for the first part we mostly did theoretical content, so basically just learning about technical content, and then we saw a nice example and you were able to replicate this on your browsers as well using OpenVibe. So for these couple hours, we'll be seeing and learning machine learning techniques for brain-computer interfaces. We'll be learning about classification and feature extraction techniques. So basically to know where to identify the features from your EEG signals. And finally, I'll be doing a live demo of a EEG headset that I have here with me, which is a Crown from Neurosity. And I'll be showing you how to pair it with your computer, how to visualize the EEG signals, and then just explore one of the features that are in their live. So yeah, I'll try to make it as interesting as possible to get you hands-on learning on this. As for the slides, I'll be sharing these slides on the Discord channel as well, because I know there's a lot of cool concepts inside here. We'll just be seeing some introduction to what is going to be happening today. Hopefully, you recharged from the last stream and ready to get started with the second part. If you weren't able to attend the first stream, it is recorded on YouTube now and it's posted on our YouTube channel. And I'll be giving also some reminders about what we saw in the past session so you don't forget. I'm pretty sure most of you already know me. My name is Jocelyn and I'm a coach here at Major League Hacking. Some of my fun facts, I like salsa dancing and I collect Minecraft Bee plushies. And I always like to put on my slide that I'm into neurotech. So hopefully today I'll be teaching you something about neurotech and how it relates to brain-computer interfaces, which, to be honest, is a topic really, it's not very related to computer science. I mean, it kind of is, but not very related. So it's more related to biomedical engineering. If you study that, it's related to that. So hopefully you'll be learning about that today so you are a more experienced developer. So the agenda for today. As for the first thing, which we already did on our last stream, we basically learned how to run the generic oscillator in OpenVibe. I can run that example again. It's super easy. We had to download OpenVibe. For the people that haven't downloaded OpenVibe yet, I'm going to go ahead and share the link on the chat so you can download it directly from there and you can get access to the tools that we're going to be using. After that, we basically built a generic oscillator in OpenVibe so we can visualize the signals. Then we are going to learn about feature extraction and classification, so basically machine learning and feature extraction. After that, we will learn a very important tool that's used on EEG signals, which is LSL, or Lab Streaming Layer, as the long name. We're going to learn about common softwares for signal analysis. So we already learned about common hardware that's used on this area, but today we'll be learning about common softwares that are used for signal analysis. And at the end, I'll be giving a live demo of the Crown from Neurosity, which I have with me today. And yeah, hopefully after this session, you will know what are BCIs and how to build one of your own. I know that this hardware is not very accessible or you cannot find it everywhere. That's why there are alternatives like public data sets or also doing your own generic oscillator like we did on OpenVibe on our past session. Awesome, so let's get started. Also, I forgot to mention that don't forget to check in. I already sent the link over in here on the chat so you can check in. Oh, this one. So you can check into this stream and get your points for the Global Hack Week. Great, so let's get started. Most of you already downloaded OpenVibe, so I'm not going to go into those details again. So basically, OpenVibe is just a platform to test and use brain-computer interfaces. It's used by biomedical researchers and labs worldwide. It's a kind of old software, but it still serves its purpose by today. And I have to say, it's one of my favorites. So definitely check it out. We already downloaded that on the last stream. So just make sure to have it. We're not going to be doing many things today on OpenVibe, but I just wanted to have it on your computer so we can have a nice demo. So let's get started. Well, I start sharing my screen for doing this live demo. I'm going to give you some time for the people that still haven't downloaded this to make sure and do it. So you'll also have access to that. Okay, so let me share my screen. Okay, so this is the downloads page from OpenVibe. We just need to download this, and this will download two things: the acquisition server and the scenario designer. So the first thing that I'm going to do once you download everything, you're going to open up the acquisition server. It's going to open up on this side of the page. There we go. Let me just close this. Awesome. Over here on the arrow, you're going to search for the generic oscillator. So this is just basically an artificial signal that's on your computer. So I don't have nothing on my screen on my head right now. It's just a generic oscillator that's going to be running, so we can just visualize a simple signal in case that we want to learn from there. You're going to click on connect, and then you're going to click on play. So now that the device is receiving data, I'm going to go ahead and now search for the designer. So once you download OpenVibe, it will download you two things. So the acquisition server and the designer section. So let's wait for it to open up. There we go. I'm going to go ahead and close this. So this was example that we built on the past stream. So now for the purpose of this demo, I'm just going to add a filter in here so you can see how a filter can affect how signals are being viewed. So first I'm going to run this so you can see how the raw signal is visualized. I have all of my channels here. The signal looks okay. I mean, there's still some noise in there. It's not very clear. It's a bit messy, but it's getting better. It keeps getting better. So let me close this. And I'm going to click on yes, stop scenario. I'm going to delete this one for the meantime. And then I'm going to search for filter. Let me see, a spatial filter, temporal filter. I think this is it. Let me see. Yep, temporal filter. This is going to be bandpass. So basically, I'm going to set a low cutoff frequency and a high cutoff frequency. So basically, only the frequencies that I want. So I can select, for example, I'm going to say from 4 to 10 hertz. I'm going to click on apply. And then I'm just going to connect the signal stream over here. And then I want to visualize the signal. So I'm going to select my signal visualizer. Signal display. There we go. Oh, I'm not being able to. There it is. Great. So I'm just going to grab this one, plug it in here. Oh, this is taking a while. Oh. Okay, this is harder to plug in than it looks like. There we go. That took a while. Great. So signal display is just basically so we can visualize our signal. In this case, it's configured to be per channel, but it can be global as well. And you can have different offsets in here depending on your use case. So I'm just going to go ahead and I'm going to save this, and then I'm going to click run. And then right now the signals are a bit messy, but they will start getting a bit cleaner. There we go. So now the signals are much more easier to read. If you see, there are some channels that can be read more easily, such as channel 2 and channel 7 and 8. they look really nice. I mean, they look like perfect signals, because these are actually artificial signals, so they will, of course, look perfect as if nothing was disturbing them. But you can basically see how signals with no noise can look like. And depending on the frequencies that you select, is how your signals are going to look. Because if you remember from the past stream, each there are different bands for frequencies, and depending on the frequencies that you have, is the mind state that you're going to be having. So, for example, we can have some frequencies that are related to deep sleep, or we can also have some frequencies that are related to concentration and so on. So with this simple example, you can basically view your signals, and you can also play around with different filters that are out there. I'm just going to stop this. So there are different filters that are out there that you can also use. I think there's this also called signal cleanup. There's also a spatial filter, temporal filter as well. I think we can use this one as well. This one is a bit different. You can also use it. Doesn't really matter. You also have stimulation filters incoming stimulation selecting or rejecting specific ranges of stimulations. But yeah, this is really cool because I'm not even wearing any headset, and you can basically just test this out, which you can basically be seeing your signal here using your generic oscillator. And you can also do different things in here. You can select different channels. So I can only, for example, if I only want to visualize F6, then I just click on apply. And now I'm only seeing signal F6. You can have simulation colors if you are having a simulations. In my case, I haven't trained any simulation, so I'm not seeing anything. But let's say that, for example, I train a left-hand simulator. So I will be able to see markers in here when the person thought about moving his or her right hand. I'm going to close that. You can also scroll, so only like seeing the signals over here. This looks really bad. I'm just going to close this. There we go. Great. So yeah, basically with OpenVibe, you can build different things. I can also show you some examples of what gas motor imagery actually looks like. So for example, this is an example of brain-computer interface using motor imagery. So in this case, we are detecting two classes. So we are detecting left class and right class. So that class, those classes can be basically anything. And I don't think it actually works with the. I don't think it works with a generic oscillator because you need to have like something trained. Yeah, I'm getting errors in here. Confusion matrix, because yeah, there's literally like zero accuracy because it's a machine, so it's not going to be thinking of something. But if I were to be wearing my headset in real time, I will be able to get a result from this accuracy, because right now it's zero. But when I was wearing the actual headset, it showed me off like a 84.7% of accuracy. So yeah, it really pretty much depends on you having the headset, so you can try these scenarios out, or using some data sets that are available online, so you can hopefully use this information that's in here. Okay, so I'm going to stop sharing my screen for OpenVibe now, and I'm going to continue with our slides. So we only have a couple more left before we go to the live demo, because I think that one will take me a while to set up. I have my headset over here, and I have to turn it on and then logging into the software and everything, so I can show you how it actually works. Okay, so there are some typical machine learning techniques that are used. It's more of a process that you need to follow in order to be having everything. So there are three important steps that you need to follow. In this slide, I only have two of the steps. I will show you the third one once we get there. So for the first one, there's some pre-processing. So pre-processing, it's kind of the thing that we were doing already. So just filtering around the frequencies that you want. In this case, you can use a bandpass filter, low pass filter, or whatever filter that you want to use for your use case. You can include it in there, and that will be pre-processing your signal. So let's say that I only want to accept frequencies that are between 0.5 to 8 hertz. So I will place my filter in there, and all of the signals that do not lie on that frequency, then I'm just going to cut them off. So that's my pre-processing. So once we go into the feature extraction, it will be a cleaner signal. The second step is feature extraction. So for feature extraction, there are several techniques that you can use. Some of the most common ones is the CSP, which is a common spatial patterns, and band power features. So for the CSP, it's basically finding spatial filters that maximize variance for one class. So I know these might sound a bit blurry, it might sound a bit confusing, but it's just basically seeing which one is more maximized when the other one is more minimized. So let's say, for example, that with a specific filter, your class, well, there's a specific pattern where your right hand class is like really increased, and then for another type of pattern, your left hand is really small. So you can use that as a pattern, so you can detect those features when you are thinking about your left or right hand. And then there's the band power features. So this one, they just basically calculate power in specific frequency bands. So again, as we're talking about electrical potentials in here, you can calculate the power that is done in a specific frequency band. And that specific frequency band can be either the frequency that you select, so 0.5 to 8 hertz, or it can be your beta waves or alpha waves. Whichever frequency that you choose, you can calculate the specific power, so you can use that as a feature for your extraction and identification, so you can make your brain-computer interface work. And then for the last technique, well, not the last technique, but the last step of a typical machine learning pipeline is the classification. So once features are extracted, you have to train a classifier. So once you know which are your left hand and your right hand features, then it's time to train your classifier. So I'm pretty sure you've heard about machine learning algorithms before. Some of the most common ones used in brain-computer interfaces are LDA, which is linear discriminant analysis. Usually you want to use that one when you only have two classes because it's linear and you can basically make just a graph and plot them using linear regression. And then you also have SVM, which is support vector machines. That one usually gets higher scores when you are training a multi-class thing, but it mostly supports two classes as well, as you can see on the screen. Usually, when doing a simple brain-computer interface, you only have two classes, so these algorithms will be able to perform really well. But when you're talking about training more classes, then it gets a bit more complex, and then you might want to be thinking about using how do I the tree classifier. I don't remember the specific name. But yep, you can use different machine learning techniques in here. So if you know about machine learning and you want to get into data analysis for EEG signals, then this is your correct spot, because you will be able to understand these algorithms and you will be able to play around with the data. Because at the end, it's just like classifying images of pets or classifying text or whatever pattern that you want to analyze with using machine learning. So for EEG signals, it works the same because you need to identify specific events that are happening on your brain, so you can then associate those events with something that you want to produce on your external device. So moving along, talking about events and how you can actually identify them, there are some things called markers in brain-computer interfaces. So markers are nothing more than events, which are small time-stamped signals inserted into the EEG recording to indicate something happened. So let's say that we have, as I was mentioning, you have your graph of your EEG signal going on, and then once you think about your left hand or your right hand or whatever thing that you want to put on as an event, then when you add a marker, when you think of that, it will automatically plot into your graph. So you can identify specifically when the person thought about that. So you can later use that to train your machine learning model and identify those features. So you can then, use them as input for your algorithms that you will be basically creating. So markers in BCI basically show you a cue on screen. The software inserts a marker into the EEG stream so the user can visualize it, and you can also know when they're going on. So it's pretty much really cool. And this basically happens that during feature extraction and classification, we use these markers to segment the EEG signals into epochs. So epochs are just basically chunks of time. You can have your epoch number one, epoch number two, and so on. So an epoch is just an amount of time that you are measuring. So by being able to place markers into your EEG signals, you know specifically when that event occurred on your EEG signal experiment, which is pretty cool using markers. I think this is one of the concepts that I struggled most on understanding what it was and what was the purpose of it. But after getting to use them, now I realize how useful they are. Because then you can actually send these markers to Python and you can use them to control like your Arduino or your motors or your computer cursor. Because at the end, once you identify that marker that you are thinking of moving your left hand, then you want to trigger the action that corresponds to thinking about that. Okay, so moving on, now that we learned about markers, now we're going to learn a bit about lab streaming layer. So lab streaming layer, it's related to signals. Yeah, it's related to EEG signals. And this is an open source software framework to stream time synchronized signals. So it's not only brain signals, it can also be used for any sort of signals. It can be heart signals, it can be muscular signals, brain signals like the ones we're using, and so on. So this is a specific protocol that's used to send these signals over our network, so we can have access to them and we know exactly that they are stamped accurately. And yeah, this is basically the protocol that we use to stream signals to other softwares. So let's say that you're using a headset that maybe doesn't have a platform to work on or to edit your signals. So how are you going to send those signals to somewhere else? So the answer is that you are going to be using Lab Streaming Layer, because Lab Streaming Layer, is official protocol thing that you use in order to read your signals somewhere else. And hopefully today at the end, I'll be trying to use this protocol in order to send the signals from my Crown device into a script in Python that I'm going to be doing as well. Let's see if we have time for that. If not, I'm just going to show you a quick demo of how it works so you can see it live as well. Okay, so let me just search super quick. What's next? Okay, let me just go super quick into searching for that one in well, so you can also see it. Let me see. There we go. So let me look for Lab Streaming Layer. Okay, so Lab Streaming Layer, it's not something specifically related to EEG, it's related to signals in general. So Lab Streaming Layer is a system for the unified collection of measurement, time series in research experiments, blah, blah, time synchronization, to make it basically real time. And then we have an example in here. Let's see. I think I saw an example about EEG Lab. Yep, it's this one. So EEG Lab is the MATLAB integration for EEG signals, which is really cool. And then in here you can also see some of the most common, where are they? Supported devices and tools. You can see all of the tools that are supported by using Lab Streaming Layer. So for example, some of the ones that I was presenting today were the Open BCI, which are all headsets. Then we also have the Muse, which we were seeing. So there's many Muse in here. The Neurosity as well, which is the one that I'm going to be using today. And yep, there's basically more in there that you can look up. There's also for eye tracking, motion capture, hardware, supported multimedia. So there's more. It's not only related to EEG signals, it's also related to other types of signals, as you can see in here. The following systems are also supported by a separate program, the OpenVibe Acquisition Server, which was the one that we were using a while ago. And then we have more signals in here. Open EEG. This one's also cool. Yeah, so there's many more. Yeah, the headset that we're going to be using today, let me find it again. It's this one. Let me open this on a new tab. So this is the one that we're going to be testing out today. Actually, I have it here. Let me see it. Here it is. So this is the one that we're going to be testing today. It's really cool. It has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It has 10 channels, so we have 10 electrodes in here. It's currently turned on. I already charged it, and I'm actually returning this one today, tomorrow. So hopefully, I was able to have the stream while I still had it in my hands because I was just at a hackathon this past week. So yeah, I was able to use it there to build a BCI project, which was really cool. Great. So this is the one that we're going to be using today. So it looks really nice. It looks so. It looks like from the future. You know, it's really nice, and it actually has an app. I can actually open it up from my phone. So let me see it. No Rosity. There we go. So this is how it looks like. There's like a complete app on my phone. Right now, I do not have it connected in here. Let me actually plug it into my Wi-Fi. So I have to turn on my Bluetooth and then pair it up so we can see. Bluetooth is connected. Awesome. And then let's connect to Wi-Fi. Let me see. Okay, I was just connecting to mobile hotspot because as right now I'm in my university. My university blocks IoT hardware. So when you try to connect something that needs IoT communication to Wi-Fi, it blocks out that request. So that's why I need to connect to a mobile hotspot, which sadly it can be my own hotspot. So yeah, which is also really cool. Well, while it's being connected, I'm going to go ahead and continue showing all the cool features that this has. So once I get it to connect, we can see what it's like. So the Neurosity is just basically built for different things. It's actually dedicated for to build brain-computer interfaces, but it can also be used to do different things. So you can also measure how focused you are. You can also measure how stressed you are, and so on. So hold on. Let me just plug. Okay. And they actually have their own SDK, which is really nice. And you can integrate that with React. So it's very easy to get started. So there's many things that the SDK can do. So one of the most common things that you can do is check signal quality. You can get a person's mental state metrics such as calm or focus. You can also train a new motor-based thought in training, and you can use that trained thought for control in something. And you can also interact with haptics as the headset has some haptics in here, so you can also look those up as well. So the reason why I like this headset so much is because it's so easy to get motor-based thought in here using the training thing. So, sad thing about this thing, I was actually testing these during the weekend, and we were not able to classify more than two signals. So I was only able to classify one signal correctly, and then the other ones just didn't work. So that's kind of sad, because I was really looking forward into using these new hardware to train more signals, but I mean, I already asked for help in their Discord, so hopefully someone who has more experience with this headset can let me know what I'm doing wrong, because there's not much to do from here. I mean, and the other thing that I can do is just export the signals and then do the training myself, because this software actually does the training for yourself, so you don't have to do the actual training. which is one of the coolest part because you don't have to be building your own algorithms and then filtering out the signals and all of that process. It does it for you. So I was really hyped to use it. But once we got it to train and the signal quality was really good, we still couldn't get to achieve two signals, so two different movements to be identified. So yeah, I guess that was a sad thing. I mean, I will still continue using it to see if hopefully I can get it to work. But yeah, by now, still no log. Let me just quick without saving. Let me just close some things. So let me close this. There we go. So getting started, there's a lot of resources in here. You can also see the API guidelines, such as like device selection. You can see how it works. It's really straightforward. Honestly, at this point, I think I've read the whole documentation. It's not hard to get to. I guess the hardest part is getting your actual motor imagery signals to work, because that was a pain for me. So for this stream, I'll be trying to use the live streaming layer so we can see if we can export those signals into Python so then we can work with them over there. And once we extract those signals, let me tell you, it's going to be easier because we can extract those signals and then import them into OpenVibe. And then OpenVibe is I bet it's a much more better software than these Neurosity SDK, because OpenVibe is widely known for having so many integrations with so many headsets. So if we're able to pull that off, then I'm pretty sure the training will be much more easier to identify those features directly from OpenBCI, from OpenVibe. Okay, so we can actually see the resources in here, and you can see the knowledge in here, which are the knowledge bases. And let's just search for LSL, which is the live streaming layer. So EEG data from Crown about device simulators. Then we also have reading data into Python via LSL. So we're going to go ahead and search this one. So reading data into Python via LSL. It's very easy. We just have to install this. Well, this is virtual BNB, so not really necessary. And then required steps: create an account, which we already have, powered on, get your Notion online, claim your Notion, activate LSL. We're going to see how to do this in a while. And then we need to install the PyLSL package from our terminal, create a new Python file, and then just copy and paste the following code into your main file. Taking from the mine, and it's called receivedata.py. So this is example program, and we are getting the streams in here from the EEG, and hopefully we'll be able to print them. It's on the same network. And yeah, after running this, we'll be able to be extracting all of the EEG signals from this. So just give me a moment so I can connect my headset, because I'm having some internet issues due to my university. I'll be back in about 2 minutes, so I can make sure to connect this or find a hotspot that I can use so I can work with it during the stream as well. Okay, so I'm back, and sadly, my mobile hotspot is not working where I'm at, and I couldn't. Um, I actually asked for the IoT network password to see if I could get it working from there, but there's no luck. Um, yeah, and I don't think by connecting this is going to work. So let me see what I can do. Let me see if I can actually go ahead and enter the page and let's see what we get. So it's in the Neurosity console. Neurosity console, there we go. And oh, I think not from here. Let me open up a Edge window because my browser sometimes just blocks things. So I'm going to open it up from Edge browser. And then we're able to see, the metrics in here, the signal quality. But as right now I have it offline, it's not, I basically cannot measure things. So if I click on start, I can't see the brainwaves in there because my headset is basically online because it needs Wi-Fi in order to connect itself and view all of the things that I will be viewing in here. So from here, you can see your metrics timeline. You can see the signal quality. So once you wear this and you actually have it on your head, then you can see what's happening in there. You can also see your metric prediction, so you can see how calm you are or how focused you are on depending on the different signals that you've trained. So, for example, for this past event, we basically trained different things in here, and how this works is that you can train a new signal. But for that, I actually need to turn this on. So I'm still figuring this out, checking if I can install it somewhere else, and then just connect using it what I have over here. So let me just see. Give me a moment. So right now I'm trying to find a way so I can connect the headset and actually show you how it's used. Because without giving the light demo, then there's no point of showing you how it works. Because we already learned all of the all of the theoretical concepts that are in there. So hopefully, we can get that live demo working for you all, and you can also keep it recorded. So in case that we want to see it again later on. Okay, so let me try one more time to get it working. Oh, I should have checked this before, honestly. Okay. Okay, I think I'm about to make it work. Just give me a moment. I'm just asking someone else to use, another mobile hotspot to see if we can get it working. Because right now, as we're not officially on break. So our school model is like we have 5 weeks of classes, and then we have like one free week that we only have one class a day, which is super chill and it's not related to the career. So it's kind of a time to just relax and have some free time. So usually the library right now it's kind of full, as there's many people just chilling and just having fun. So, a network is not really good for hotspots, especially. I mean, the Wi Fi it's good, but you cannot use IoT devices on our local network. And I actually tried connecting to the IoT um, account, Wi Fi account that we have at our university, but it's also not working. Okay, so I think it's up and running. Let me just double check on the dashboard to see that. Let's see. I think we're only missing. Let me try to turn it off and on again. So it's. Let me turn it on again. Mm. So you actually see like the red light of turning off. And let me turn it back on. There it is. So this one, blue, it means that it's still in pairing mode. So I'll just give it a while for it to connect again. But now I think it's actually going to work on this one. So Bluetooth devices. Let me see. Mm. Huh. I think as I'm pairing it with a new device, maybe I need to put it in pairing mode. I don't know. Let's see. It's actually easier when you use devices that are not connected through the internet. So most of the devices that I've used before are using just Bluetooth. So you only pair it with your Bluetooth. Doesn't matter if you have internet connection and then you get it working. But I think this one, works a bit different. Oh, awesome. So now we can see that it's connected. So that's perfect. Okay, so let's just go ahead and go to brainwaves, and I'm just going to click on start. So right now I'm not seeing anything as I currently don't have it on. So let's see if we can see the actual quality of our signals. I don't think it's paired because it's not showing things. So right now I'm wearing it. The thing is that I don't think it's connected because I'm supposed to be seeing something in here. I mean, it's not like I don't have brain activity. Um, it's weird because it's actually connected in here. I'm able to see it on my account. Oh, I think it's just disconnected. Too bad. Hmm. Let me see. Okay, well, I guess the live demo won't be able to happen due to internet connection issues. That's so sad, but I have a video of this thing working. So hopefully I can search that video and show it during the live stream. Let me just find it so I can share with you all and we can see how it's working. So let me open that post because I actually have it on that post. And you can see some example of what the signals look like. Let's see. Watch on YouTube. Okay, let me open it up over here. So you should be able to see the video in here. Let me move it to where we. So in this case, we're using the neurosity crown, and then you're being able to see the brain waves in there, which is really cool. Let me see if there's another demo. Oh, here's another one of how it looks like. So in here, you can see your focus, and you can also measure your different things that you basically train there, and then you get to see how the electrodes are being calibrated onto the signals in there. Like that, which looks really nice. And yeah, let me see if there's another demo in here. I think those were all of them. But yeah, I guess that's a nice demo of how it works. Honestly, I really wanted to get it working on stream so you can see it live. Too bad that I had to be on my university really late, but I had things to do, work to get done. Yeah, I owe it to you, so we can share it on the next stream. As for now, I'll just go back to our slides to see some final things in here. So lab streaming layer, we already saw that this is our kind of a standard to be sending the signals over. We were not able to show how that works on real time, as I was not able to pair this. The Wi-Fi, well, not the Wi-Fi, but my network on my phone, it's really bad. So I even tried with another phone that I have from a friend, and it also didn't work. So let's move on. Some of the common softwares that are used, we already learned about OpenVibe and how to use it, but there's more. OpenVibe is not the only one. There's also MATLAB. They have a special toolbox called EEG Lab, which is pretty awesome, to be honest. Then there's also the BCI 2000, which is another one that's used in order to test brain-computer interfaces and build your own projects. That one is not related to specific hardware. It's also very, very open, like OpenVibe. And there's also BrainFlow, which is also another cool one. It's also used for brain-computer interfaces. This is just a list of some of the examples that are out there, but there's definitely more. And every headset that you basically use, they have their own SDK that you can use in order to start building stuff. So, for example, the Neurosity has its own SDK, but there's also other headsets that have their own software, so you can start, viewing all of the things that are in there in order to test them out. So to be honest, when I started using this one at first, I thought it was really cool because you can have all of the motor imagery and get it working. But once I started using it, honestly, there were some challenges, because I could only train one signal, and then when I tried training two signals, it just couldn't make a difference between them, which was pretty lame. And when I was using the Unicorn Hybrid Black, I got it working at my first attempt. So yes, it was really stressing to make all the recordings and start recording basically everything. But yeah, so what else do I have prepared in here? Oh yeah, this one's for the end. So let me see what else can I show you. Let me see if there's if I can showcase some of the different projects that are out there. So you can see the different headsets. So, I wasn't sharing that screen. There we go. So this is my university lab where I can basically borrow all of the hardware that I'm using right now. And I want to check if there's somewhere where I can see the projects. There we go. Mm, there we go. I think it's loading for a while. Let me see. Oh, this is taking a long time. Mm, I want to see. Oh, there we go. So here are the devices. So this is one. It's called Next Mind, which is mostly measure the visual cortex of the user. So everything related to where you're looking at, these thingy in here will be able to detect it, and it actually has its own um, its own SDK, so you can also test it. And here's a YouTube video about how to use it and how to place it on your scalp. You know, you just put it on and then it goes on the back side, so you can test it in there, which is pretty cool. And then there's a user manual. Then we also have the Muse headset. So this one has pretty cool things. It has EEG signals, it has accelerometer, oximetry, and gyroscope, and it has 4 electrodes, which is this one. And here's also a video about how you can place it. Mostly used for meditation and sleep. So this is more commercial friendly. It's very user friendly and simple to get started. So you download the app and then you just get it running. So this is a headset over here. It has 4 sensors that you wear it at your forehead. So that's how you actually use it. It looks really neat. I mean, it looks very modern and it's comfortable as well. And then you can see some of the biometrics in there. There's then we have the unicorn heartbeat bag. This mostly measures EEG signals. It has 8 channels, so it's quite heavy. And then here's what it looks like, but it's missing the scalp, the headset. And then this is how it looks like. It looks really, really experimental. You need to turn it on, and then you need to add the saline solution because they're basically wet electrodes, and then you use a unicorn visualizer, the unicorn suite, so you can see all of the signals plot in there. Huh, weird. Then we also have the Enovio 8, which is this one that I also have used before. This one has more channels. I think it's up to 32 channels, which is really cool. But yeah, these are some of the examples. We also have some of the eye tracking ones. This is called Pupil Core. You wear it as glasses, and then you can basically measure eye movement from there, which is also really cool. We also have the gaze point, which is mostly like a camera that you put it in there, and then you'll also be able to track user movement from their eyes, and you can measure like the hotspots from where the user is seeing the screen and so on. We also have other headsets that are more, well, not headsets, more like wearables to measure skin temperature or activity based on movement for like sports and things like that. So this is called Empatica E4, which is a wristband. It's really big, and I wouldn't say very comfortable, but it's used for. Take a look in here. It's kind of big. You wear it like a clock. I have to admit that it doesn't look very friendly. I mean, it's not very pretty, but you know, it works. And then you also have the shimmer, which is this one. You also wear it. We have another shimmer ECG in here. Then we have the Embrace Plus. So for this one, I actually built a third-party software to use, so you can obtain the direct files from here and visualize it on a Streamly dashboard, because it was really hard to get these files to work through their own software. It was not beginner friendly. So my goal was building a dashboard that was easier to understand, so users could actually use it correctly. And then we also have the OI motion. This one, I think I've only used it once. It measures EMG signals. I think it's like a Chinese wristband, so there's not really much support on this one. Not much documentation online, but it's also really cool. And yeah, that's basically kind of the hardware that I've used before. I honestly have used all of them. Looking forward to use more. The Crown is one of the newest acquisitions, and we also have more new headsets that haven't been documented on the web page. But that's one of the cool ones in there that you can also use as well. Great. So I know I'm ending this stream a bit sooner than I would like to. I would have loved to give the demo. Sadly, it's not under my, it's not under my reasons for not to get this working. I will for sure be making more streams about EEG, BCI signals, and also more robotics and more hardware to get us started. I know I mostly do streams related to AI, related to LLMs and computer vision, but hopefully I'm starting a new initiative on doing more hardware and more visualization on these topics that sometimes can be a bit hard to understand by hackers, in hackathons or just in general projects that they want to do by themselves. Okay, so thank you for having me during these two sessions. I know we saw a lot of content. I'll be sending the slides on the Discord soon. Feel free to fill out these form for feedback to tell us how we did, if there's something that you would like to improve or recommendations or just give shout outs about the stream. I'm going to drop it on the chat as well so you can fill it out. And yeah, if you haven't checked into the event, make sure to check in here so you get your points for the weekend. I won't be having more streams for this Global Hack Week as this is basically the last day. We only have closing ceremony tomorrow. But yeah, I'll be seeing you on the next Global Hack Week with much more content to share, very interesting topics, and hopefully live demos that will be working. I'll see you later, and yeah, have some rest and some fun for the rest of your day. Bye, everyone.